Okay, so let's start another part, which is fx equals to x plus greatest integer function x. Greatest integer function is also called floor function. It is called greatest integer function because for any decimal point, for any value of x, it will be providing the integer value which will be nearest, lesser, or equal to that value. The floor function also has this different symbol which you can see on the screen, and now I am going to elaborate how this floor function works. So if we operate this on 3.2, 3.2 is a value, so it will be giving us the value 3. 3 is the nearest and lesser than 3.2. For 0.9, it will be providing the value 0 because 0 is nearest and lesser than 0.9. What happens when we operate the same floor function on 1.0? It provides us 1 because 1 is nearest and equal to 1.0. So another example that we can see are negative values. So for minus 1, it will be providing us minus 1. For 0, it will be providing us 0. So these are some examples which we try to see. Now going back to our function fx, the first part is only x, which is a linear straight line function, and we can draw it simply as a 45-degree angle straight line on a coordinate system. Okay, so now let's jump back to our floor function and let's understand how we can plot this on a coordinate system. So for that we establish a coordinate system xy axis, and we give some points on x-axis which are 1 comma 0, and another is 2 comma 0, and third is minus 1 comma 0, and another point we put on x-axis which is minus 2.0. So we have already seen that the for value 0, the floor function will be providing us value 0. So now let's see how it will behave between 0 and 1. We have already seen an example by 0.9, which will be providing 0, and also for 0.2 it is providing the value 0. So we can say that between 0 and 1, the function floor function which when operates provides us value 0, but at point 1 it behaves differently and it gives us value 1, and for that reason we cannot include this point on our graph at 1. We will have to jump for the reason that function value will increase from 0 to 1 suddenly as soon as we apply the floor function on 1. And now let us see some more values to give to the plot. And at 1, the value of greatest integer function for 1 is 1, which we plotted as a point, and then for 1.2 the floor function provide the value which is greatest nearest integer, which is 1. So we just plot the function as a horizontal line till the value reaches to a sudden jump to 2, because what happens when we put greatest integer function for 2.0, it jumps to 2, but before that it has the value 1. So that's why, and so on and so on, the function will keep continue. Now this is for positive x values, but now we will try to understand how the floor function will be plotted and will be behaving for negative x values. And for that we need to find out how floor function will operate and behave for negative x values. And by the definition we know that the floor function will be providing the greatest integer which is nearest and also lesser or equal to the given value. So for minus 0.2, the nearest and the lesser and also the greatest integer is minus 1. For minus 1.0 it is minus 1. For minus 2.3 the floor function provides the value minus 3. Between value of x minus equal to minus 1 and 0, we will be having the floor function value as minus 1. But what happens at 0? At 0 it jumps. That's what I have shown in the figure as a jump point, and I have not included it, and it is not to be included. So dark circles mean the point value is included, and the hollow circle means the value is not included. And then we move on to gather more points and to plot them as well to see how our curve will be for negative x value. So we find out minus 1.3 has a floor function value of minus 2, and another point minus 1.9 we operate floor function, it came up as minus 2, and one another point minus 2 which has floor function value as minus 2. So we see that for x values between minus 2 and minus 1, the value is going to be as minus 2. At x equal to minus 1, the value is minus 1. So we will not include that point, we will keep it as an hollow circle, but at value minus 2, the circle is darkened because it is included. So let's just check for a value minus 1.5 and operate floor function on it. It gives us minus 2, which we can see we have drawn on our uh, figure. And there is a jump from value minus 2 to minus 1, which is very abrupt because it's floor function. Okay, so as of now we have both our functions plotted. We have floor functions plotted. We have straight line y equal to x plotted. So now we will do one thing. We will try to plot the f of x, which is the sum of floor function and straight line function. So for that we are going to need points, and those points we will be plotting. So for x equal to 0, we have the function f of x value as 0 plus floor function 0, which is equivalent to 0. For x equal to 0.5, we have 0.5 plus floor function 0.5, which is equivalent to 0.5 plus 0, which is equal to 0.5. And then we are going to need one more point, and for that we take x as 1.0. So for that fx equal to 1.0 plus 1.0 as floor function being operated, which is equal to 2. Okay, let's just take one more point, which is x equal to 0.9. For that f of x will be 0.9 plus greatest integer function 0.9, which will be equivalent to 0.9. And so if we try to see the pattern how the greatest integer function is behaving, that's what we had already concluded from our floor function, which was telling us that between 0 and 1, floor function gives value as 0, which has turned out to be true once again. And so our function f of x will be equal to x only between 0 and 1. So between 0 and 1 our function is only reduced to as being x, fx equal to x. Greatest integer function is providing only 0 value. So now we can start defining our function fx for different domains, and right now we have got fx for x belongs to 0 to 1 as being only x, fx is equal to x for all the x belongs to 0 to 1. So we can plot this on our coordinate system. So this is just an straight line equation, fx equal to x, but it is only for the domain 0 comma 1. So we draw this, and also one thing to be pointed, at 0 the function is having value 0, so we will include that point. But at 1 what happened was that function jumped, f of x value jumped to 2, so we will not include that point, we will keep it hollow and darken the circle just above it at a value 2, fx equal to 2. And if we try to plot with more points, then we will find that the function will be looking just like another straight line between x value 1 to x value 2. We have just shown this. You can also try it in the same manner as we did for values between 0 to 1. Okay, so now let's start to find out uh, fx values for negative x. For that we are starting with minus 0.5, and we see that minus 0.5 plus floor function minus 0.5 is going to give us minus 1.5, because floor function is minus 1 between the value of x which belongs to minus 1 to 0. The floor function gives minus 1 between minus 1 and 0, and that's an interesting property of floor function, because floor function again giving a constant value which is going to add with a straight line function x in our function f of x. So just another point, for instance, for minus 1.0 the function f of x will be minus 2 minus 1.0 plus floor function minus 1.0, which is equivalent to minus 1 which is equal to minus 2. And we have now enough points, and if we need we will try to find out. And so at minus 1 the f of x is giving value minus 2, and at minus 0.5 it has value minus 1.5. Okay, so now we have enough data, enough points. Now we can try to plot the function for negative x value between minus 1 and 0, and this comes up as a nice straight line. And at point 0 you can see that we have put an hollow circle, because the value becomes 0 we cannot include it. And you can see a jump there, and jump says that the function is not going to be differentiable between minus 1 and 1. And if and there is, you can clearly see a discontinuity, there is a break, function is not continuous, function is not differentiable at point 0, and function is structuralizing, to be honest. And for option C we have option R as a correct answer, and option S as the correct answer. Okay, so now we can define our function fx finally, and it will be 0 at x equal to 0, and for x belongs to minus 1 to 0 it will be x minus 1, because greatest integer function is providing a constant value minus 1 between minus 1 and 0.